Look at a short example of using GCF in a word problem, just one word problem example, so you can see how GCF might be applied in a word problem situation. And students do sometimes have some difficulty trying to figure out how to solve a problem like this and understanding that GCF is something that they can use. Sometimes they don't quite understand that this is the concept that they're applying. So 28 candy bars and 42 packs of gum were put in gift bags. The same number of candy bars and the same number of packs of gum were put in each bag. What is the greatest number of gift bags that can be made? So this problem's not saying that the same number of candy bars and the same number of packs of gum are the same. They're saying the same number of candy bars go in every bag, same number of packs of gum go in every bag. So we could do a couple things. If the students don't know that they're supposed to use a way to find greatest common factor, they could make a bag. Okay, that's a bag. And they could make a bag and a bag. Okay, and they could say, all right, what if I do 3 bags? And they could do a little bit of guess and check. All right, well, 28 candy bars, they could, even make little slashes for the candy bars if they wanted to. But 28 is not divisible by 3, right? So if I put 28 candy bars, I could do 9 in each one. 9 would give me 27, but that means I have 1 left over. So that's not going to work. I can't use 3 bags. I could do 4 bags. 28 can be divided by 4. I could do 7 and 7 and 7 and 7. Can I do that with 42? No, but see, here we're checking, like, what is 28 divisible by? What are its factors? So we had a factor of 4. We could do 4 bags. Could we do 7 bags? Let's see. 6 bags. 28 can't be divided into 6. 28 can be divided by 7. We could do 7 bags. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. If we did 7 bags, that would mean we'd have 4 candy bars in every single one. So that works. What about 42? Can 42 be divided into 7? 1, 2, 3, 4. 42 divided by 7 is 6, right? So we could do 4 candy bars here. 4 candy bars. 4 candy bars. 4 candy bars. 4, 4, and 4. And then we can do 6 gums. That's 6 gum. 6 gum. 6 gum. 6 gum. 6. All right, so it looks like we can make 7 bags. The greatest number of bags? Is that the greatest number of bags I can make? Can I make more bags than that? Well, let's see. 28 can also be divided by 14, right? So I could do 14 bags. Can 24? Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Okay, so here I had 7. If I have twice as many bags, I'm going to have half as many things in each bag, right? So 28 divided by 14 is 2. That would give me 2. 2 candy bars every time. I'm not going to write it every single time, but you get the idea. 2 candy bars. What about 3? Is 42 divisible by 3? If you remember me talking about divisibility rules in one of the lessons, the check for divisibility rules is add the 4 and the 2 together. 4 plus 2 is 6. If 6 is divisible by 3, 42 is divisible by 3. So it goes in 1 time. Oh, it's 14. Okay, so the greatest number of gift bags would actually be 14 gift bags. Wow, that is a lot of gift bags. And in every gift bag, I would have 2 candy bars and 3 packs of gum. All right, so that's one way students can solve. They can solve by simply drawing a picture like that. And depending on their level of thinking, they may need that visual. That might be the best way for them to solve it. If, however, I'm going to delete some of this just so I have a little bit more room, delete as much as I can. That's all it's going to let me delete. I'm going to get rid of some more. Now, if students looked at this and said, okay, it's asking me for the greatest number, and I'm going to be dividing my gum and my candy bars into groups. So I'm going to be dividing, and I want the biggest number possible. If I'm dividing, I'm going to be looking for factors. So we could use my favorite method. We could use the ladder method and look at this and say, all right, what is the largest number that 28 and 42 have in common? We could divide by 2 and get 14. That's really bad. We could divide by 2 and get 21. 14 and 21 are both divisible by 7. That means 14 divided by 7 is 2, and 21 divided by 7 is 3. 2 and 3 are no longer divisible. They are prime numbers. So that means my GCF, or the greatest number of bags that I can have, is 14. And this part tells me that I have 2 candy bars in each one and 3 packs of gum in each one. And using the ladder method in that way, once students understand that they're dividing these and they're looking for the biggest number that they can divide them by, when they can recognize that this is GCF, then they can use the ladder method. They also could list out all the factors and find the biggest one, and they also could do prime factorization. But that is just one short example of using a word problem to apply GCF.